Let's read number 7. It says, use a calculator to find the population standard deviation of the times of the following table. Because this table contains all winning times for this race up to year 2012, the data set is a population. So it's very important here that because it's a population, we know what we need to use. Because it's a population, we have to use the number 4 on our calculator, which is the sigma x. That is the population standard deviation. So we're straight up using our calculator in this one. In this one, I want you to know what's number 1, which is in. Number 2 is your mean. And I also want you to denote number 4. Be careful not using number 3. You want to use number 4 in this case, which is the population standard deviation. So how do we do this? Again, you're hitting on your TI 30XS calculator, you're hitting data. You're going to hit data a second time, hit enter to clear out the list. You're going to type in every single one of these numbers into list 1. After you've typed in every one of these numbers to list 1, you hit second data for stat, hit enter on one variable statistics, make sure L1 is selected on the first one, make sure the word 1 is selected on the next one, and hit enter for calc. That's going to give you the data that you need. When I use my calculator, I'm getting the quantity was 12. Rounding to 2 decimal places, I'm getting 49.46, and this is in terms of seconds, was my average. And I'm getting a standard deviation of 1.02 seconds. So the population standard deviation is 1.02 seconds. So what does that mean? It means they usually run about 49.46 seconds, but over 80% of the data should lie between about, I'm just going to say roughly 48 and 55 seconds, or 50.5. So 48.5 and 50.5, roughly. Okay, just add and subtract that standard deviation from the mean. So that gives you a nice range of where the majority of the data values lie. Look at example 8, same thing here, large data sets, horrible numbers. I would never expect you to do this by hand. I always want you to use a calculator on these applied examples with bad numbers. Don't worry about doing these by hand. It says use your calculator to find the population standard deviation of the race times of the following table. So again, this is population. That tells us that we're going to be using sigma x. So I want you to use your calculator. Once you use the calculator, look at number 1, which is how many there are. Look at number 2, which is your mean. And then look at number 4 in this case, which is sigma x, the population standard deviation. Go ahead and enter those numbers into your calculator now. Again, in data, it's data a second time. Enter to clear out L1. Type in all these numbers. That'll take you a minute. Once you're done with that, hit second data for stat. Hit enter for one var statistics. Make sure L1 is selected for the data. Make sure the word 1 is selected for the frequency. Hit enter on calc. Read off the values. I'm getting 2.7, 46.09, and 2.48 as my standard deviation. 2.48, and this is in terms of seconds. So you have 46.09, it asks for the standard deviation. So the standard deviation would be 2.48 seconds. That's my standard deviation. So what does that mean? I'm just going to say that's roughly 2.5 seconds. So 46 is where most people come in, but the vast, vast majority of people would come in between, well, you would subtract 2.5, which would give us 43.5, and you would add 2.5, which would give us roughly 48.5. So most of these values are between 43.5 and 48.5 seconds. The vast majority of this data is what we're saying. Okay. The last thing that you need to do for measures of dispersion is calculating the variance. We do not get into this deep at all, but variance is used in statistical measures, statistical research, so I at least want you to know what variance is. Variance is very, very simple. Okay, so let's read this. It says a statistics known as the variance is also used as a measure of dispersion. The variance for a given set of data is the square of the standard deviation. So it says the following chart shows the mathematical notations that are used to denote standard deviations and variance. So if you have sigma, that's your population standard deviation, just do the square of that, that's your variance. If you have S or S of X, that's your sample population standard deviation, then just square that number. That gives you your variance. So to find the variance, quite simple. To find the variance, all you're going to do is take the standard deviation, whatever your standard deviation is, and square the dang thing. That is your variance. It's as simple as that.